Now we are going to introduce chemical bonding. So actually chemical bond or the formation of chemical bond is always exothermic. First point you should know that. Formation of chemical bond is always exothermic. So whenever two H atoms combine to form H2 molecule, the energy released is 104.5 kilocalorie per mole. Actually, along with the equation, we write the energy released as plus. If you want to write delta H, you have to write minus 104.5 kilocalories. Because it is always exothermic. Exothermic reactions always have delta H negative sign. So for the first point you should understand in chemical bonding that the formation of chemical bond is always an exothermic process. Always energy is released. Now the second point you should know, in the formation of chemical bond, forces of attraction is equal to forces of repulsion. So during the formation of chemical bond, which forces are balanced? Forces of attraction is identically equal to forces of repulsion. Because whenever two atoms approach each other, each atom is surrounded by some electrons, negative electrons, centrally located nucleus. So how many repulsions occur? Electron-electron repulsions occur. Nucleus-nucleus repulsions occur. So whenever two atoms are approaching each other, definitely there will be some repulsions between like charges. What are those like charges? Electron-electron repulsions and nucleus-nucleus repulsions. Two types of repulsions exist. If repulsions dominate, atoms never come together. They always keep away from each other. And never a chemical bond is formed. At the same time, in spite of the repulsions, there is some attractions also. There are some attractions also. This nucleus can attract this electron. This nucleus can attract this electron. So whenever two atoms approach each other, in spite of electron-electron repulsions, in spite of nucleus repulsions, there exist some attractions. What are those attractions? The nucleus of first atom can attract the electrons of the second atom, and vice versa. The nucleus of second atom can also attract the electrons of first atom. So these are called attractive forces. So how many forces are operating when two atoms approach each other to form a chemical bond? Two types of forces: net repulsive forces, net attractive forces. When a chemical bond is formed, when these forces are equal to each other. So in the formation of chemical bond, the net attractive forces are balanced by net repulsive forces. At that point of time, the atoms lower their energy and they acquire a stable state. They are held by that weak attractive forces. What are the attractive forces? The nucleus of first atom attracts the electrons of the second atom. Similarly, the nucleus of second atom attracts the electrons of first atom. At that point of time, what we say, the chemical bond is formed. This is the second point you should know. The third point, formation of chemical bond is also explained by one more concept called potential energy concept. Potential energy concept. So that potential energy concept, we have to plot a graph between potential energy and the distance between atoms. When two atoms are far away from each other, their potential energy is fixed to be 0, above 0 positive, below 0 negative. So when this 0 potential energy comes for the atoms, when the atoms are far away from each other, when two atoms are far away from each other, means they have no attractions, no repulsions, they are far from each other, then their potential energy is 0. When atoms are approaching each other, the potential energy decreases. So let us say here, they are here, still nearer, still nearer. So as the atoms are coming closer and closer, the potential energy decreases from 0 to negative side. Suppose if you push the atoms even the lowest potential energy, repulsions dominate, suddenly their potential energy shoots up. So at the minimum potential energy at which the two atoms are held with each other is called bond distance. The distance between the two atoms is called what? Bond distance. So I can ask a question like this. The distance between the two atoms corresponding to the lowest potential energy is called, I repeat, the distance between the two atoms which corresponds to the lowest potential energy is called bond distance. This is the third important point you have to know in the starting of the chemical bond. Now the next level of development in chemical bonding is Louis Cosel's electronic theory of valency. So write the next heading, Louis Cosel's electronic theory of valency. Louis, Lewis hyphen Kossel, Cossel, Louis Cossel apostrophe S, Louis Cosel's electronic theory of valency. So these are the two scientists who first explained the formation of chemical bonds between atoms of different elements with a rational explanation by observing the electronic configuration of inert gases. What Louis and Cossel observed, the electronic configuration of inert gases, they observed. When they observed the electronic configuration of inert gases, what they found? Helium has 1s2 and all others have 8 electrons in their outermost shell. Only helium has 2 electrons. All other elements have how many electrons in their outermost orbit? 8 electrons. And they are very stable. This is the observation made by Louis and Cossel. They have not conducted any experiments, just they observed. What they observed? Helium is very stable. It is not reacting with any others. Like other inert gases also, they are not able to react with others. Why they are very stable? They observed. They found that the 1s2 configuration of helium is very stable configuration. That's why it is not losing electrons, it is not gaining electrons, it is not sharing electrons with others to form chemical bonds. Similarly, the other inert gases, neon, argon, krypton, xenon, radon, they are also not reacting with any others. Of course, nowadays in the modern science, by providing some special conditions, we are able to force the xenon to form certain compounds. So, actually Neil Bartlett, what is his name? Neil, Neil, Bartlet. Neil Bartlett is a British scientist. He is doing an experiment. He wants to combine the O2 plus ion see the Neil Bartlett experiment. So what he has given, he has supplied 1175 kilojoules of energy to what? To whom? Oxygen molecules, not atoms. Then oxygen molecule lost 1 electron and form a positive ion. And this O2 positive ion combined with PtF6 minus platinum hexafluoride ion, and immediately it forms a red color solid O2PtF6. Oxygen platinum hexafluoride. Then immediately he thought, okay, what is the ionization energy of O2 molecules? I mentioned there 1175 kilojoules. Generally, ionization energy is measured for atoms, but this is molecule. So the ionization energy of molecular oxygen is how much? 1175 kilojoule per mole. So when this energy is supplied, O2 is losing an electron and forming a positive ion. Correct? And that positive ion is combining with a negative ion. What is that negative ion? PtF6 minus. When these two ions combine oppositely charged, they form a solid ionic compound called oxygen platinum hexafluoride, a red color solid. So that's fine. His research is that. But he thought, okay, any other element is there whose ionization energy is around 1175. 1175 kilojoules energy. Is there any element in the periodic table to have this ionization energy? Immediately he found that xenon is having 1174 only kilojoule per mole. He supplied that energy. Immediately xenon forms Xc plus electron. Now this xenon plus he combined with PtF6 minus. And immediately got another red color solid, XePtF6. Xenon platinum hexafluoride, a red solid. This is the first inert gas compound prepared in the laboratory. What is the first inert gas compound prepared in the laboratory? XePtF6. Xenon platinum hexafluoride. By whom? Neil Bartlett. Before Neil Bartlett, nobody is dared to attempt to make any inert gas compounds. Actually, Neil Bartlett aim was not to prepare inert gas compounds. His aim was only to unite the O2 plus ion with whom? PtF6 minus. And meanwhile, he got an idea, is there any other element which is having an ionization energy of around 1175. He found immediately xenon. So he supplied same energy, 1174 kilojoules of energy. Immediately xenon formed Xc plus. Then he tried to combine with the PtF6 minus. Immediately they combined with each other and formed xenon platinum hexafluoride. That is the first inert gas compound prepared in the laboratory, which is in our NCERT syllabus, a NEET question also. So don't think it is outside the syllabus. So this is how Lewis and Cosell, what they observed, whom they observed, and what they observed. The simple answer is Lewis and Cosell observed the electronic configurations of inert gases. And what they observed? Helium has 1s2, all other elements have ns2 np6, means 8 electron configuration in their outermost shells. So they called this 8 electron configuration as stable octet. This is a stable octet. This is stable duplet or doublet also. Duplet or doublet or duet, you can use different names. And because of this duplet or stable doublet, helium is not reacting with any other elements. Because of stable octet, the other inert gases, neon, argon, krypton, xenon, radon, they are also not reacting with any other elements. So immediately Lewis and Coasel proposed the reason for other elements to form chemical bonds, they want to get stable inert gas configuration. Why other elements try to combine with each other? While combining, they want to lose electrons or gain electrons or share electrons. Finally, they want to acquire stable doublet or stable octet. So what is the reason for the atoms to combine to form chemical bonds? By Lewis Coasel's electronic theory of valency, what it says, the reason for the formation of chemical bonds by elements other than inert gases is due to the fact that they acquire stable outer configuration, either by losing electrons or by gaining electrons or by sharing electrons. This is called octet rule. Write octet rule. Atoms other than inert gases, atoms other than inert gas elements try to acquire stable doublet or stable octet configuration stable doublet or stable octet configuration either by losing electrons, either by losing or by gaining, either by losing or by gaining or by sharing of electrons. And this is known as octet rule. And this is known as octet rule. Now, number of electrons, next point, lost or gained. The number of electrons lost or gained to acquire stable octet is known as electrovalency. Next point, the number of electrons shared. To acquire stable octet is known as covalency. Now look at this illustration. Okay, look at this. Write the heading. Ionic bond was proposed by Cosell. Ionic bond was proposed by Cosell. And covalent bond was proposed by Lewis. Subheading: ionic bond or electrovalent bond. Ionic bond or electrovalent bond. Actually, this bond is formed between a metal atom plus non-metal atom. What is the primary condition to form an ionic bond? It is a combination of a metal atom and a non-metal atom. In the formation of ionic bond, the metal atom loses electrons. You stand up. The metal atom loses electrons, not you, loses electrons. That means it undergoes oxidation. Now, yesterday you asked a doubt, that's why I am pointing at him. Undergoes oxidation. So, loss of electrons is oxidation and acts as a reducing agent. Reducing agent. Agent always undergoes oxidation. A reducing agent always undergoes oxidation. Number 2, the non-metal atom non-metal atom gains electrons and undergoes reduction, thereby it acts as an oxidizing agent. So the very simple concept, ionic bond is always formed between a metal atom and a non-metal atom. What the metal atom do? It loses electrons and undergoes oxidation. When it loses electrons, it becomes a positive ion. The non-metal atom gains electrons. When it gains electrons, it becomes a negative ion. So in the formation of ionic bond, if metal atom loses electron, it forms a positive ion. If non-metal atom gains electron, it becomes a negative ion. This positive ion and negative ion are held by strong electrostatic forces of attraction. Those electrostatic forces of attraction are called ionic bonds. So precisely what is an ionic bond? It is an electrostatic force of attraction that binds the oppositely charged ions, which are formed by transfer of electrons from one atom to another atom. So if you don't know the definition, you can write the definition of ionic bond. What is the definition of ionic bond? It is an electrostatic force of attraction. It is an electrostatic force of attraction that binds the oppositely charged ions which are formed by transfer of electrons from one atom to another atom. From one atom to another atom. And one more conclusion here. Formation of ionic bond is a redox reaction. Formation of ionic bond is a redox reaction. Why we are calling it as a redox reaction? Because in the formation of ionic bond, who is losing electrons? The metal atom. And undergoing what? Oxidation. Who is gaining electrons? The non-metal. And undergoing what? Reduction. So oxidation and reduction both are occurring. That's why ionic bond formation is what? A redox reaction. Here we can also touch one more point, which is even relevant to the earlier chapter periodic table. If an atom loses electrons, just listen to this, it becomes a positive ion. Similarly, if an atom gains an electron, it becomes a negative ion. So when an atom is converted to a positive ion, its size decreases because it has lost electron. The electron cloud density decreases, size decreases. When an atom gains electron and becomes a negative ion, its size increases. If an atom is converted into an ion, I am not specifying which ion it is, its size may increase or may decrease. Based on this, commonly asked question like periodic table, the decreasing order of size, H comma H plus comma H minus. So we say H minus is greater than H plus. Similarly, I minus is greater than I plus. Actually, this is related to periodic table, but we are covering here. A negative ion is always larger than its parent atom. A positive ion is always smaller than its parent atom. Next point. Generally, ionic bonds are formed between the highly electropositive elements, between the highly electropositive elements of first and second groups, and highly electronegative elements of p block, and highly electronegative elements of p block like nitrogen, oxygen, N comma O comma F, Cl, Br and I. So what are the different combinations to form ionic bonds? The elements of first and second groups, which are highly electropositive. What is meant by electropositive nature? Tendency of losing electron, means when they lose electron they become positive ions. And highly electronegative elements of the p block, such as nitrogen, oxygen, fluorine, chlorine, bromine and iodine. Generally these combinations produce ionic bonds. But what are the two exceptions? What are the two exceptions in the first and second group which predominantly form covalent bonds? Dr. Frank. Dr. Rocky. Lithium and beryllium. Yesterday we already discussed. Okay. Luckily, what I observed in the study session, most of you are concentrating. It's a very good sign. Some of you are also discussing with each other. I don't know whether it is subject or some other matters. Mostly observed, subject matters are discussed with others. That mutual discussion of subject matter with others, there is nothing wrong. That will benefit both of you or the group involved. But don't deviate from your path. Maybe 5-10 minutes you may deviate, but immediately you have to come back to your normal position. So that you should develop. Don't look at the chairs whether the teacher is observing you or not. You should not observe whether teacher is there or not. You should concentrate, because your aim is to become doctors, and the government of Meghalaya is spending money on you. Correct or not? So it is a very good initiative. Already this type of initiatives are taken by many state governments across the country. Maybe this is the first time that the government of Meghalaya is doing this project. Governments are doing two things, not only for this type of competitive exams. After your graduation, they are also providing total financial freedom, that you can prepare for civil services exams also in top institutions of the country. The top institution in the country is Vajiram and Ravi in Delhi. So this Vajiram and Ravi, both are names. Vajiram is the old man, he is the father-in-law. His son-in-law is Ravi. So they teach general knowledge, geography, current affairs and all. They take around 150, I think 150 students. A single day admissions are closed. They keep around 20 seats for recommendation from central ministers, prime minister, because it is in Delhi. All ministers are there, member of parliaments are there. They put so much pressure. That's why around 20 seats they keep for recommendation. All the remaining 150 filled on a single day online admission. Over, khatam. But civil services, definitely you have to go to a bigger city where exposure is more, like Delhi, Hyderabad, Bangalore, Chennai. These are all the major cities. Mostly Delhi and Hyderabad are in the top for civils coaching. Governments are also offering, like this program, free coaching for civil services. They select certain candidates, they pay money to that particular institute, you can freely study. They give some money for books also. So governments are taking good initiatives. You have to utilize, don't misuse that what they are providing for you. So every minute you have to remember that. So government is spending huge money on you. They are booking flights for us, up and down flight charges, this. So all this, they pay money for us. It's very huge money involved in this project. So you should feel responsible. Don't be irresponsible. And do your work. Result will automatically follows. Without doing work, don't dream of you are going to happen something. Or God will help you and do some miracle in the last. That is if you are on the edge. Suppose you are in the border. God may help you. Maybe on that day, you may corrected 10 wrong answers as right answers. Your marks will be scored will be 40 marks than expected. Definitely will be a rank holder. That is luck factor. Basically, you should reach a benchmark. Crossing the benchmark or below the benchmark is luck factor. Okay? So I don't want to waste much time. Next point. Write the next point. Favorable conditions. Favorable conditions for the formation of ionic bonds. Favorable conditions for the formation of ionic bonds. I think while erasing, these are all overlap. I don't know how to get back. Later you check. After writing the heading, favorable conditions for the formation of ionic bond. Write the subheading favorable conditions for the formation of cation. Favorable conditions for the formation of cation. So what are the favorable conditions for the formation of cation? Number 1, large atomic size. Low ionization energy. Less charge. On the cation. So all these three we can explain in a very simple way. Suppose you have a small atom, you have a big atom, from which we can remove electron easily. Small or big? Big. Bigger atoms can lose electron easily and form cation easily. So among alkali metals, which readily form the cation? Is it lithium or cesium? Cesium, because down the group size increase. Cesium can form cation more easily than lithium. So what type of atoms can easily form cations? Atoms of larger size. And this is related to ionization energy. If the atom size is large, electron removal is easy, means ionization energy is less. So lesser the ionization energy, easier the cation formation. The third point is, I give you an example, Na plus, Mg2 plus, Al3 plus, which is formed more easily. Is the cation with 1 unit plus charge, or is the cation with 2 plus, or is the cation with 3 plus, which is formed more easily? The answer, cation with less charge, because that requires first IE. If you want to remove 2 electrons, you have to supply IE1 plus IE2. If you want to form cation with 3 units of charge, you have to supply IE1 plus IE2 plus IE3. So cations with higher charge are formed with more difficulty than cations with lower charge. So what are the 3 favorable conditions for the formation of cation? These 3. Similarly, write the heading, favorable conditions for anion formation. Favorable conditions for anion formation. Now you yourself can tell. What about size of atom? Big or small? To form anion, is it the size of atom should be large or less, small? Smaller atoms can easily gain electrons and form negative ions. That's why the first condition is small atomic size. Now the second condition, high electronegativity or electron affinity. High electronegativity or electron affinity. The third condition, less negative charge on the ion. Less negative charge on the ion. Look at this example. F minus, O2 minus, N3 minus. Which is formed more easily and why? The answer is F minus is formed more easily. Why not O2 minus and N3 minus? Because addition of one electron is easy for an atom. After adding one electron, the atom becomes uni-negative ion. For uni-negative ion, if you add the second electron, then it becomes bi-negative ion. For bi-negative ion, again if you add one more electron, it becomes tri-negative ion. First electron addition is easy. That is called electron gain enthalpy, and it is always exothermic. But second electron gain enthalpy, third electron gain enthalpy, they become positive, means they are endothermic. So addition of one electron to a neutral atom involves release of energy, exothermic process, and it occurs readily. Addition of two electrons or three electrons for an atom involves EA2 and EA3. EA means electron affinity 2, electron affinity 3, which means they are endothermic. That's why it is very difficult. So F2, F minus involve addition of one electron. O2, O minus, first you have to convert O into O minus. O minus again add electron to convert O2 minus. This is difficult because this is negative repulsion. Similarly, to convert nitrogen, first you have to convert N into N minus, N2 minus, N3 minus. Means you have to add one electron here, one electron here, one electron here. This is easy. N to N minus easy. N minus to N2 minus, N2 minus to N3 minus. This is very difficult. Why? Negative repulsions. So anions with less negative charge are easily formed than anions with more negative charges. Now write the examples of ionic bond. Examples of ionic bond. Now the first example I am giving, NaCl. Now Na with the 2-8-1 configuration, 1s2, 2s2, 2p6, 3s1, 2-8-1. This is the configuration. 2 electrons, 8 electrons and 1 electron. And the last electron we put as a dot. Now this Na want to lose this last electron. Then it becomes Na plus electron. Then it will have 2-8 configuration. Stable octet configuration. Stable octet. So why sodium is readily losing an electron? To acquire stable octet. Now write the Cl. Cl is having 287, means 1s2, 2s2, 2p6, 3s2, 3p5. So in the last orbit, how many electrons are there? 7. It can't lose 7 to acquire octet, but it can easily gain an electron. 7 becomes 8. So here I am putting 7 dots. It takes one electron from sodium. After acquiring that electron, Cl becomes Cl minus, and the configuration becomes 288, means 1s2, 2s2, 2p6, 3s2, 3p6. Again stable octet. Stable argon configuration. Now two ions are formed. One is Na plus, the other is Cl minus. Now these two ions, this Na plus and Cl minus, because of their opposite charges, they are strongly held by electrostatic forces, which is called ionic bond. These electrostatic forces present between the positive and negative ions are non-directional. So for ionic bond, you need not write any line between Na and Cl. Just the positive and negative ions combine with each other by electrostatic force. So write that point. Ionic bond is just an electrostatic force. Ionic bond is just an electrostatic force that binds the oppositely charged ions, and it is non-directional. Directional. Here one more point, if anybody recalls, you can answer. If the bonds are non-directional, the compounds cannot exhibit dash kind of isomerism. Ionic bonds are non-directional. They are just electrostatic forces. Because of the non-directional nature of the ionic bond, ionic compounds cannot exhibit dash type of isomerism. Look at this. Here I just kept a tetrahedral arrangement. In the tetrahedral arrangement, all four are different. It is a totally black, bulky. This is lean. This is having black cap, this is having blue cap. Now in this tetrahedral arrangement, the bonds are directional. If I remove this from this place and put this one here and this here. This is a different arrangement, a spatial arrangement. Earlier this marker pen, electronic pen, is projecting towards you. Now a normal ballpoint pen is projecting towards you. This is in the upper direction. This type of different spatial arrangements, due to the directional nature of the bond, gives stereoisomerism or space isomerism. So stereoisomerism or space isomerism is due to different spatial arrangements of groups or atoms. Since ionic bonds are non-directional, they don't have any different spatial arrangements. That's why they cannot exhibit space or stereoisomerism. A very important NEET question. Write that point. Since ionic bonds are non-directional, they cannot have different spatial arrangements. They cannot have different spatial arrangements, and hence they can't exhibit stereo or space isomerism. And hence they cannot exhibit stereo or space isomerism. Suppose I want to convert this point into assertion reasoning type question. Please listen, no need of writing. Suppose if I give assertion, ionic compounds cannot exhibit stereo or space isomerism. This is my assertion. If I give the reason, due to non-directional nature of the ionic bonds, that is the reason. What is your choice? Option 1, correct. Option 1. Both are true and R correctly explains assertion. So any point we can convert into a question. Multiple choice or assertion type. So actually what we expect, the student should learn the subject in such a way they themselves are able to frame the questions. That level you have to reach by April 31st, 2025. How much effort you do, that is up to you. So you should have that much ease to even think of framing of questions. Because whatever we discuss in the classroom, generally in the final exam they come. Every year it is a common thing. Students come with excitation. Sir, many questions, whatever you discussed, they came in the exam. It is not a great thing. We are discussing the entire syllabus. Obviously the questions are set in the syllabus. They have to come. So don't think that questions will come from sky. Questions come from within our syllabus framework. So within the syllabus framework, we should be very thorough and exposed to different type of questions. Learning concept is one thing. After conceptual learning, exposing to different varieties of questions. That is second thing. So these are the two things required for you. Next example. First example we finish NaCl. Second example, potassium oxide K2O. Potassium oxide K2O. So in this, first write K, atomic number 19, 1s2, 2s2, 2p6, 3s2, 3p6, 4s1. If you divide this, it becomes 2881. 2881. So I write potassium like this and write below 2881. The last electron I put as a dot. These are called Lewis electron dot structures. Whatever we are writing are Lewis electron dot structures. Now this K want to lose an electron and become K plus. This electron is lost, then it becomes 288, stable argon configuration. In the formula there is K2O, that's why I write one more K and do the same. So how many electrons are lost? 2 electrons from 2 potassiums. 2 potassium atoms, each one lost one electron. So somebody should be there to gain these 2 electrons. Then oxygen comes to the rescue. So oxygen, atomic number 8, 1s2, 2s2, 2p4. Means oxygen is having 2p4, 2, 6. What is oxygen configuration? 2, 6. So 6 electrons, I write as 6 dots. Now these 2, 6, they take 2 electrons from 2 potassium atoms. Oxygen is gaining how many electrons? 2 electrons, which are transferred by potassium atoms. Then oxygen become O2 minus and its configuration become 2,8. 2,6 become 2,8. Now these 2 K plus ions combine with O2 minus to form K2O. This is our second example. Homework or hostel work, HW. Similarly, you write aluminum fluoride, sodium fluoride, potassium sulfide, potassium chloride. These are all your for practice. Now, and lithium fluoride. Now, instead of heading, here one important point is there. That also you can make a note. What this point, please, if delta En, electronegativity difference, this point only you note. If electronegativity difference between two atoms is greater than 1.7, ionic bond is formed. Okay. Which one?
If the electronegativity difference counts 1%,
Exactly 1.7, 50% ionic, 50% covalent. If greater than 1.7 electronegativity difference, predominantly ionic. Actually, earlier it is mentioned as 1.9, but now they are telling it as 1.7. Less than 1.7 difference, covalent. So if the electronegativity difference is greater than 1.7, predominantly ionic. If it is exactly 1.7, 50% ionic, 50% covalent. If it is less than 1.7, it is predominantly covalent. You also copy this magnesium oxide. Third example. Magnesium oxide. This one. Mg is losing 2 electrons. Here I write 282. Magnesium atomic number is 12. Here I write 26. This become 28 now. This also become 28. And the resulting is MgO. You have to write like that. Or magnesium oxide is a refractory. MgO is a refractory. What is a refractory? The one which do not melt or even become soft even at high temperatures. So those substances which do not melt or even become soft, however high temperatures are used, are called refractory materials. Graphite is a refractory. Magnesium oxide is a refractory. In the American Space Shuttle program, they use a lightweight refractory materials to cover the entire shuttle, because the shuttle crosses the atmosphere and enters into space. while crossing to cross the atmosphere and enter into space, you have to give escape velocity, which is very high. If you provide the shuttle with that much high velocity, it faces huge amount of friction from the atmospheric gases. This friction makes the shuttle to catch fire and blast. That's why, to protect the shuttle from the friction of the atmospheric gases, when it crosses the atmosphere or when it re-enters into atmosphere, shuttles are reusable. It goes into the space, re-enters into the Earth atmosphere. 2 times it faces a very difficult task. That is, it faces huge friction from the atmospheric gases. So to protect it, it is completely covered with a lightweight refractory materials. Then only it won't burn down, otherwise it will easily burn down. So like that, the shuttle goes into the outer space, returns from the outer space to the Earth, particular specified center. So the only problem is if any refractory material has gone in the journey, some gap is there, that will face extreme friction from the atmospheric gases. That will catch fire and the entire shuttle will blast. That happened when our Indian-born astronaut Kalpana Chawla, she is a Punjabi girl who went to space from American space program NASA. While her shuttle is coming back, one refractory tile below the wings of the shuttle has gone, and that causes the accident, and the entire shuttle blasted in the mid-air and all the occupants died. So that is the thing. That's why nowadays they are taking extreme precautions. So recently that Sunita Williams and one more astronaut who are in the ISS, International Space Station, actually they went to stay there for 1 week. And the space program, they launched this one, Boeing Corporation. Boeing Corporation, after so many setbacks, it has launched a rocket or shuttle. It went into space and dropped them there and came back. When they want to bring them back, there are many problems are arising with the shuttle they used by the Boeing company. Now Elon Musk also offered our SpaceX shuttle will bring them back. And Russians have almost same technology. They also promised to bring them back. But now they went for 7 days. Now they have to stay up to February next year. They can't come back. So the human mind is so complex. To look at the shuttle program, space program, we can't imagine also how the brain is working. Doctors copied this for the surgery. Earlier surgeries are almost failures, mostly failures. The patient is on a surgical table, whether he survives or not, God's grace. But doctors thought when an aeroplane takes off with so much of luggage, so many passengers, and safely reaches the destination, why can't we do an operation on the ground? So they compared the program of a pilot. It is a very stringent program. Pilots have to fill so many gaps in their books, log books. What is the reading of this altimeter, this, that. They have to talk to the air traffic controller, maintain a log book, they have to fill a lot of data. The data is very much analyzed. Like that, doctors also introduced a protocol in surgery. So in surgical operations, the anesthetist comes. Depending on the body weight of the patient, he will give anesthesia. And another person will be monitoring the blood pressure. Anesthetist is monitoring the anesthetic levels. Surgeon is doing surgery. Pulmonologist or cardiac surgeon is looking at the heart if it is a complex surgery. So like that, just like the flight takeoff and landing, many parameters are taken care of. In surgery also nowadays, many parameters are taken care of. Just they copy from the aeroplane takeoff and landing, how many parameters they take care. Similar parameters they are also taking care of. And that's why most of the surgical operations are nowadays 100% successful. Success rate is too high. Very rare cases on surgical table the patient dies. Even the complex heart surgeries, the cardiothoracic surgeons perform with utmost care and protocol. Earlier the protocol is not there. Simply they cut and open the die. But nowadays protocol is there. So like that. Okay, now properties of ionic compounds is our next heading. I think we already discussed factors favorable for formation of ionic bond, cation formation, large atomic size, low ionization potential, low charge on ion. Inert configuration is common, that need not be mentioned. Factors favorable for anion formation. Okay, what we will do, these points we simplify. This is very lengthy. So here I write, some more space I need. Here I write properties of ionic compounds. First property I write, they are crystalline solids. With high melting points. High melting points. Number 2, soluble In polar solvents, like water, do not conduct electricity in solid state. Reason: no free ions. Conduct electricity in molten or fused state, or in aqueous solutions. Due to free ions. Do not exhibit stereo or space isomerism. Ionic reactions are fast and spontaneous. So 1, 2, 3, 4, 5. Now the first point, they are crystalline solids. Dr. Tommy, what is meant by crystalline solid? Which one? Solid. All solids can be called crystalline. Is glass is crystalline? Not studying. What is a crystalline solid? Doctor, your name? Very good. She is able to give the answer. Orderly arrangement of constituent ions in a three-dimensional pattern. What is a crystalline substance? It is not only a solid, no doubt. Of course, nowadays liquid crystals are also there. LCD display. You have LCD display TVs. Liquid crystal display. Now we have quantum displays nowadays. The top end televisions. Nowadays we are using quantum dot technologies. Okay. This is the orderly arrangement. Suppose if we take sodium chloride, these are all chloride ions. In between sodium ions will be there, an alternate arrangement. This is how the orderly arrangement comes. This is orderly arrangement. Let us say this is Cl minus, this is Na plus. So Na plus Cl minus, again Cl minus, again Na plus. Like this is the orderly arrangement. This type of orderly arrangement in a 3D pattern is called crystal lattice or crystal or space lattice. All ionic compounds are crystalline solids. To break this crystal, very high amount of energy is required. Thus their melting points are high. Look at the second point, which is very important. Ionic compounds are only soluble in polar solvents like water. Why they are only soluble in polar solvents like water? The reason, the solvent molecules, the polar solvent molecules, pull the oppositely charged ions. Pull the oppositely charged ions so that they separated. So that they get separated and dissolves. So I'll explain like this. Suppose NaCl, Na plus Cl minus, if it is placed in water, water has partially positive hydrogens, partially negative oxygen. This is called polar molecule. What this polar molecule will do? The positive end will attract the negative ion. The negative end will attract the positive ion. So why when NaCl is dissolved in water, the salt in your mess, when you dissolve in water, immediately it is soluble. But the same NaCl, if you put in petrol, even one single crystal is also not soluble. Because petrol is non-polar, kerosene is non-polar. So ionic compounds are not soluble in non-polar solvents. They are only soluble in polar solvents. Why they are only soluble in polar solvents? Because the poles of the solvent molecules, they attract or pull the oppositely charged ions, so that the ions get separated. Once the ions get separated, the compound is soluble. Actually, Yesterday some student asked me a doubt. Sulfate solubility. Barium sulfate, magnesium sulfate. Second group sulfate solubility doubt. Who asked me yesterday? So the person who asked doubt also forgot, but I remember. That is very funny. Sulfate solubility. Write a point here. The solubility of ionic compounds in water depend on two factors. Depends on two factors. Number one, the lattice energy. Number two, the hydration energy. Next point. Top to bottom in a group, for any type of particular compound, both lattice energy and hydration energy decrease. Both lattice energy and hydration energy decrease. But not in equal magnitude. Full stop. Next point. If the lattice energy decreases more rapidly, RAPIDLY, more rapidly than hydration energy, the water solubility of the compounds increases down the group. The water solubility of the compounds increases down the group. Example, the oxides and hydroxides. Of first and second groups. Next point. If the hydration energy decreases, more rapidly If the hydration energy decreases more rapidly than lattice energy, the water solubility of the compounds decrease down the groove. Example, the sulfates of second group. Okay, I'll explain all these 3-4 points in a very simple way. Actually, whenever an ionic compound dissolved in water, two energy factors are involved for their solubility. One energy required to break the lattice and free the ions. Just now you learned that lattice is orderly packing. That packing should be broken so that the ions get free. Then it becomes soluble. So the energy required to break the lattice is called a lattice energy. Once the lattice is broken, the ions get separated. Each ion attracts n number of water molecules and the ion is surrounded by water molecules. Whenever a particular ion is surrounded by water molecules, the ion is surrounded by water molecules, its stability will be more. That's why some energy is released. That is called hydration energy. So what is hydration energy? It is the amount of energy released when 1 mole of ions are surrounded by n number of water molecules. What is hydration energy? It is the amount of energy released. Release remains within brackets exothermic. Hydration energy is always exothermic. It is the amount of energy released when 1 mole of ions gets surrounded by water molecules. Get surrounded by water molecules. What is lattice energy? Right. It is the amount of energy required to break 1 mole of crystal lattice. It is the amount of energy required to break 1 mole of crystal lattice. And separate the ions in free state. Both lattice energy and hydration energy both lattice energy and hydration energy are inversely proportional to size of ions, directly proportional to charge on the ions. group, what happened to the size of atom? Increases. When size increases, lattice energy decreases. When size increases, hydration energy also decreases. So down the group, for any particular type of compound, two factors decrease. What are the two factors? Both lattice energy and hydration energy both decrease due to increase in the size of ions. But though both decrease, they don't decrease in equal magnitude. One decreases more rapidly than the other. Suppose if lattice energy decreases more rapidly than hydration energy, the compounds become more and more soluble. The reverse. If hydration energy decreases more rapidly than lattice energy, the solubility decreases down the group. Based on this, if you look at the sulfates of second group, beryllium sulfate, magnesium sulfate, calcium sulfate, strontium sulfate, and barium sulfate. Sulfates of second group, water solubility decreases. Water solubility. Means barium sulfate is the least soluble. Beryllium sulfate is most soluble. Now based on this simple chemical factor, doctors perform a test called barium meal test. Even today it is a valid test. So the barium meal test is based on the insolubility of barium sulfate in water. Suppose somebody is having some gastric problems. He visits a gastroenterologist. He has many tools to check your gastric, entire digestive tract. He can do with an endoscope, gastroendoscopy. They will send a small wire into your stomach. At the end there is a small bulb. So that is rotated inside, and on a monitor you will see the entire your digestive system. Any tumors are there, any rupture is there, many things they notice. Or sometimes they need X-ray. Sometimes these two are not valid. They ask the patient to drink a glass of barium sulfate. Barium sulfate is human consumable. It is insoluble, suspension. It is not a liquid, a solid liquid mixture. It is insoluble. That the patient has to swallow. After allowing to sit for certain time, then they will do an X-ray examination. The insoluble barium sulfate in the stomach, in stomach also it remains insoluble. Even barium sulfate is insoluble in concentrated HCl also. Stomach secretes HCl that can also not able to dissolve it. It remains insoluble there. So when X-rays are passed, whatever the barium sulfate in your stomach, it is having an excellent scattering power for the X-rays. So this barium sulfate in your stomach scatter the X-rays in all directions. When X-rays are scattered in all directions, you will get a clear picture of the stomach. Without barium sulfate, if you directly pass X-rays, they pass straight. Only you will get a small portion of the stomach as an X-ray. If you want the entire stomach X-ray, inside somebody should scatter the X-rays. Who will do that job? This test is called barium, MEAL, barium meal test. So barium meal test is based on the insolubility of barium sulfate in the stomach, and during X-ray examination, the insoluble barium sulfate scatter the X-rays to maximum extent, so that we get a clear picture of stomach. Now the next point, these two are interrelated. In solid state, there are no free ions or are held in the crystal lattice. So in solid state, since no free ions, no free movement, non-conductors of electricity. But in molten state or fused state, if you melt sodium chloride, the ions separate. That is called molten state. What is the other name? Fused state. Or when you dissolve in water, aqueous solutions, they conduct electricity due to the presence of free ions, not free electrons. Metals conduct electricity, graphite conduct electricity due to free electrons. Ionic compounds conduct electricity due to free ions. In which state free ions are there? Molten or fused state, or in aqueous solutions, but not in solid state. Already fourth point we discussed. Why they do not conduct, why they do not exhibit stereo or space isomerism? Yes, due to non-directional nature of the ionic bond. Again right, what is that? Due to what? Non-directional nature of ionic bond. The last property, ionic reactions are fast and spontaneous. The reason is, since the oppositely charged ions participate, they immediately combine and the reaction within no time it completes. You can't measure its speed. For example, you take a test tube containing sodium chloride solution, a test tube containing silver nitrate solution. Sodium chloride solution contains sodium ions, chloride ions. Silver nitrate solution contains Ag plus NO3 minus. When you mix these two, when you add this to this, immediately you will see a white precipitate of silver chloride. So ionic reactions are fast, spontaneous or instantaneous because of the participation of oppositely charged ions. So these are all the properties of ionic compounds. Write the next heading, Fajon's rules. Fajon's rules. to explain the covalent nature of an ionic bond. Fajan's rules are meant for what? To explain the covalent nature of ionic bond. In Fajan's rules, you should know 2 points. One is polarizing power of cation. The other is polarizability of anion. So we will discuss these 2 points after a short break. Polarizing power, polarizability. Okay?
This side, so it will have
What's our brilliant compound, sir?
then it should have both of the
Yes.
so variance of
Only not flowing, they are ionic compounds. I'll tell you, don't worry. You are just went in a wrong track, I will say. So here, Fajan's rule, covalent nature in ionic compound. This diagram is more important. So under the heading of polarizing power of cation, you write this diagram. So the tendency of cation, tendency of a cation to prove the electron cloud. Electron cloud of anion is called polarizing power. Already we discussed once, again I am repeating. So this is a positive ion. This ion is pulling the negative charge or electron cloud of the anion. This pulling nature is called polarizing power. Next, tendency of anion. Tendency of anion to shift its electron cloud, to shift its electron cloud. towards the cation. It's called polarizability. Once you know these 2 points, polarizing power and polarizability. So polarizing power is the tendency of a cation to pull the electron cloud of anion. Anion, if anion also obliges, okay, the cation is pulling, let me shift my electron cloud towards the cation. That tendency is called polarizability. Now according to Fajon, next point, according to Fajon, cations with high polarizing power and anions with high polarizability will have more covalent character. Next point, polarizing power of cation is inversely proportional to size of the cation. It is directly proportional to charge on the cation. Similarly, polarizability of anion. Polarizability of anion is directly proportional to size and also directly proportional to charge. So polarizing power and polarizability. Polarizing power is inversely proportional to cation size, directly proportional to charge, and polarizability directly proportional to size, directly proportional to charge. For example, in alkali metals, the polarizing power decreases in this order: Li plus, Na plus, K plus, Rb plus, Cs plus. So here I increase the size of font also. Cation size is increasing. Which is the smallest cation? Lithium plus. That's why it has highest polarizing power. In second group, in group 2. This is the decreasing order. Beryllium 2 plus, magnesium, calcium, strontium and barium. Suppose if I give you Na plus less than Mg2 plus less than Al3 plus, polarizing power. Why Al3 plus has more polarizing power? Due to more charge. It is directly proportional to charge, inversely proportional to size. Similarly, polarizability. Polarizability. Now I minus greater than, Br minus greater than, Cl minus greater than F minus. Polarizability. N3 minus greater than, O2 minus greater than, F minus. Polarizability. Write a point. Among lithium halides, LiF, LiCl, LiBr, Li. This is only ionic. All the remaining are covalent, and covalent nature increases now we asked, my dear lithium fluoride, why you are ionic while all of your brothers are covalent? We asked lithium fluoride, why my dear lithium fluoride you are only the ionic compound while your brothers LiCl, LiBr and Li, they are covalent and their covalent character is increasing. Then Li plus is common among all those. In all lithium halides, what is the common? Li plus. Means polarizing power is common. Polarizing power is common. Only polarizability differs. Since F minus is small in size, Li plus, F minus. Now Li plus says, I have more polarizing power. I want to pull your electron cloud. F minus says, my dear foolish Li plus, you can't pull my electron cloud. I am also being smaller. My electron cloud is tightly held by my nucleus. So it is the least polarizable. Though it has high polarizing power, the other partner is not cooperating. Fajan suggested cations with high polarizing power, anions with high polarizability will have more covalent character. So here who is non-cooperating? F minus. It is not willing to shift its electron cloud towards Li plus. But if you come to LiCl, Cl minus is somewhat big when compared to F minus. Cl minus is bigger in size. That's why when it pulls the electron cloud, it says, okay, I will shift my electron cloud. Some polarizing power, polarizability, both are there. That's why it has some covalent character. If you go to LiBr, Li plus, Br minus, even bigger anion. Even when compared to Cl minus, it is still big. That's why when Li pulls that electron cloud, Br shift more electron cloud towards itself. So it is more covalent than LiCl. Finally, if we come to Lii, I minus. So when Li plus pulls this electron cloud, I minus happily shifts its electron cloud because it is big size, loosely held electron cloud. Smaller ions will tightly hold their electron cloud. Bigger one have loose electron cloud. Maximum it shifts to that. That's why it has the maximum covalent character. It has maximum ionic character. So what is the decreasing order of covalent character? Lii greater than, LiBr greater than, LiCl greater than, Lif. This is the covalent character decreasing order. Write an assertion reasoning type question. Already asked in the JEE or NEET, I don't know, somewhere, national level competitive exam this asked. Lithium chloride is soluble. This is assertion. Lithium chloride is soluble in non-polar solvents. In non-polar solvents like benzene. In non-polar solvents like benzene. Reason: due to its covalent character. So what is your answer? Actually, ionic compounds are only soluble in polar solvents like water. Covalent compounds are soluble in non-polar solvents like benzene. So why lithium chloride is soluble in benzene? Is it a right statement or wrong statement? Just now we discussed. Lithium chloride is having some covalent character. So because of its covalent character, lithium chloride is soluble in non-polar solvent like benzene. That's why here also the answer is 1. Both are true and R correctly explains the assertion. Which one?
Electronegativity difference in lithium chloride.
Lithium chloride is covalent, it is true.
Yes, sir. Electronegativity difference is 2. So it is more than 1.7. So ionic character is more.
You are only doing one aspect. There are many aspects for each compound. You are seeing the electronegativity difference. Cl is 3.0. What is lithium? 1. You have seen the data. So our Dr. Rocky, what he is saying is lithium electronegativity is 1. He found some in data. Actually, metals do not have electronegativity. How they give 1, please check once again. Metals are electropositive. Metals do not pull the electron cloud. Please check. Electronegativity. It is given. Textbook it is given. Yes. In textbook it is given, we have to accept. So lithium chloride in lithium has electronegativity value of 1. Chlorine has an electronegativity value of 3. Difference is 2. So what Dr. Rocky is arguing is it is more than 1.7. If electronegativity difference is more than 1.7, it should be ionic, no doubt. Actually, all halides of first group should be ionic. But lithium of first group, beryllium of second group predominantly form covalent compounds. Because one more factor is dominating there. Actually, lithium chloride forms, beginning it forms as an ionic compound only. Once the ions are formed, this lithium plus will do an extra job. What is that extra job it is doing? It is pulling the electron cloud of Cl minus. That is what is polarizing power. So because of its polarizing power, because of the polarizability of Cl minus, it is developing covalent character. As per data, predicted nature is ionic. Why it has covalent nature? One more factor is dominating. That's why when such contradiction arise, you look at all other factors. Okay? Same, that is the case we are discussing about beryllium sulfate and barium sulfate also. So Dr. Rocky is also want to argue in beryllium sulfate, BeSO4, Bu2 plus is small. It will pull the electron cloud of sulfate. So it has relatively more covalent character. Last one, barium sulfate, has more ionic character. That's why barium sulfate should be more soluble as per our Dr. Rocky's argument. But we have given reverse answer. Barium sulfate is the least soluble. But actually, in terms of covalent and ionic nature only we are predicting. But actually, whatever the ionic compounds, their solubility depends on 2 energy factors. That is lattice energy, hydration energy. So this and that, the overweighing factor will dominate. Okay? So actually, write one more point. AgF, AgCl, AgBr, AgI. Water solubility. Covalent character. Ionic character. Yes. water solubility decreases, covalent character increases, ionic character decreases. AgF is water soluble. AgI is a bright yellow precipitate. Actually, in all these, which is common? Ag plus is common. Ag plus has pseudo inert gas configuration. Electron configuration. This is N-1, S2, P6, D10. This is called 18 electron configuration. Electron configuration is called pseudo inert gas configuration. Cations with pseudo inert gas configuration have very high polarizing power. So this is having high polarizing power. But when it want to pull the electron cloud of the F minus, will F minus will oblige or reject? It will reject, because it is being very small. Though Ag plus want to pull that electron cloud, F minus clearly says no, I don't shift. Thus it is the least polarizable. Though it has high polarizing power, its partner is least polarizable. Thus it is predominantly ionic. AgF is water soluble because of its ionic nature. That's why in Lessein's test for the detection of elements, fluorine cannot be detected. There is one test in your NCERT syllabus called a Lessein's test for the detection of elements in organic compounds, in which there is an important point. F cannot be detected by Lessein's test because AgF is water soluble. Write that point here only. Fluorine in organic compounds cannot be detected by fluorine in the organic compounds cannot be detected by Lessein's test or sodium fusion test. Lessein's test or sodium fusion test. So in the Lessein's test or sodium fusion test, F cannot be detected because the formed AgF is water soluble. Because the formed AgF is water soluble. while repeat in Lesson's test he is asking repetition. I am repeating the statement. In Lesson's test F cannot be detected because AgF is water soluble. Over. If Cl minus is present in the organic compound, if Cl minus is present in the organic compound, it gives a white precipitate of AgCl, and Br minus will give a, if Cl minus is present, it give a white precipitate with AgNO3 or white precipitate of AgCl with AgNO3, and Br minus gives a bright yellow precipitate and I minus gives a bright yellow precipitate of AgI with AgNO3. So I will explain this point. Suppose if any organic compound contains fluorine or chlorine or bromine or iodine, we perform a test called Lesson's test or sodium fusion test. In the sodium fusion test, you can't detect F minus because the formed AgF is water soluble. But if Cl minus is present, immediately it will give what precipitate? A curdy white precipitate of AgCl. If Br minus is present, you will get a colored precipitate, pale yellow. If I minus is present, a bright yellow precipitate of AgI. So because of the different colors, white, pale yellow and bright yellow, you can detect Cl minus, Br minus, I minus. Why not F minus? Because the formed AgF is water soluble. NaCl, MgCl2, AlCl3, which is the most covalent. Cl minus is common in all of them. In all of them, which is common? Cl minus is common. So what is different? Cation is different. And the positive charge on the cation increases. So with increase in positive charge, polarizing power of cation increases. Then covalent character increases. So aluminum chloride is the most covalent. Write that point. AlCl3 is the most covalent. Due to high polarizing power of Al3 plus. Due to high polarizing power of Al3 plus. Now, the lattice energy of ionic compounds is determined by Born-Haber cycle. The lattice energy of ionic compounds is determined by Born-Haber cycle. Actually, in thermodynamics also, we will study this. In chemical bond also, we are discussing this. 2 times a double advantage. See the formation of NaCl in a direct step. This is direct formation. Of NaCl, in which 1 mole of sodium is combining with half mole of chlorine gas to form NaCl solid. It is an exothermic reaction. How much energy is released? 410.5 kilojoule per mole energy is released. Now the formation of NaCl can be studied in number of steps. What is that number of steps? Here I am writing. Direct step is sodium solid, half mole chlorine gas gives NaCl solid. Some delta H is equal to minus 410.5 kilojoule mole inverse. Now sodium solid can be converted into sodium gas. Whenever a solid is converted into gas, it is called a sublimation, and the energy we provide is called sublimation energy. Plus S. Plus S is nothing but sublimation energy. This is 108.7 kilojoule per mole. This gaseous sodium is supplied with ionization energy to become Na plus gas. Similarly, half mole of chlorine gas is supplied with half bond dissociation energy. You will get chlorine gaseous atoms. This will gain electrons and become Cl minus. Here the delta H is equal to negative, which is called electron gain enthalpy. Now finally what you got? 2 oppositely charged gaseous ions. They directly combine to form NaCl solid. Here some energy is released called lattice energy. So this is a cyclic process. This is a direct combination. This is stepwise. So this is called Born-Haber cycle. So what is the lattice energy? The U is called a lattice energy. Once again I repeat, sodium chloride formation can be studied under 2 headings. One is a direct combination. Na solid plus half Cl2 gas gives NaCl solid. Delta H is some value, minus 410.5. Same sodium chloride formation can be studied in a stepwise manner. So what are the different steps involved? I am presenting there. Solid sodium is converted into gaseous sodium. Solid to gas, we have to supply some energy that I mentioned as plus S. It is called sublimation energy. The gaseous sodium atoms are supplied with some more energy called ionization energy plus IE, and we can remove an electron. Sodium gaseous atoms become sodium gaseous positive ions, Na plus. Similarly, half mole of chlorine gas, Cl2 molecules. Cl2 molecule, if you break the bond, you will get chlorine atoms. If you take 1 mole, we call bond dissociation energy D. If you take half mole, it is half D. You will get chlorine atoms. This is called bond dissociation energy, breaking the bond. So that is what we have mentioned here. Now that Cl gaseous atom, it taken an electron plus E minus and becomes Cl minus. Whenever a neutral atom gains an electron and become a negative ion, it releases some energy. That energy is called electron gain enthalpy or electron affinity. Now you have two ions, Na plus gaseous ion, Cl minus gaseous ion. These two ions can combine to form NaCl solid. So cycle is completed. This is called Born-Haber cycle. When these two oppositely charged ions combine to form NaCl solid, again some energy is released. That is called lattice energy. That is represented with U. Write a point. According to Hess law, according to Hess law or Hess's law, Hess law of constant heat summation. According to Hess law or Hess's law of constant heat summation, the enthalpy change in a chemical reaction in a chemical reaction is the same when it is carried out in single step or multiple steps. Single step or multiple steps. Now write this. So delta H is equal to minus Q, that is equal to S plus IE plus half D plus EA minus U. Here also one mistake, minus EA, minus E. Better that step again I repeat. Just 1 minute. So Na plus half Cl2. Here let us say delta H is equal to minus 410.5 kilojoule per mole. This value I am taking as minus Q. So this minus Q should be equal to S plus IE plus half D minus EA minus E. Now I want to calculate lattice energy. U I will bring this side. U is equal to S plus IE plus half D minus EA plus Q. So this is the final equation to find out the lattice energy. What is Q here? Heat of reaction. What is U here? U is lattice energy. Now what the Hess law says, the heat released in a one step, that is Q, the heat released in a single step is equal to the entire heat in all steps. That's why I equated this Q, heat released in a single step, to with all multiple steps heat changes. What are in multiple steps? Sublimation energy, ionization energy, half bond dissociation energy, electron affinity, lattice energy. These are all involved in stepwise process. So you go through this. This is Born-Haber cycle to determine the lattice energy of ionic compounds. What is the law involved in this? Hess law of constant heat summation. What is Hess law? It is nothing but the enthalpy change occurring in a single step is equal to the sum of enthalpy changes of all the steps. So this is Hess law. That is applied, and finally we are calculating U. What is U here? Lattice energy. Okay.